Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
Buddy, it's been a long time since we've recorded a show, since Oslo, right?
Yeah. Well, you know, this is what happens when you get that fall conference run and we get a bunch of stuff while we're traveling, and then we get kind of a break. So Here we are. Suddenly it's November. We're recording shows again, but it's good to be back in the studio. It's good to be home.
So go ahead and ask me what I've been up to since Oslo.
What have you been up to since Oslo?
Oh my God. I did a 5-day WebAssembly Blazor training class, hands-on, but it wasn't on site. However, the team was in Ireland.
Cool.
And I had to get up at 3:30 in the morning and be online from 4:30 to 11:30.
But a full week class. It's been a while since you've done one of those.
Yep. It was cool. Yeah, I had to add a few modules and add some things. I had to transcribe some Blazor Train episodes and update the code. But yeah, I got a great 5-day WebAssembly hands-on class now. Just in time for .NET 7, which I did not talk about.
No, it's clearly going to be an important version of .NET too. So
yeah, and
there's lots of we'll make this in another show, but there's lots of conversations going on about long-term support and what versions of .NET matter most and that kind of things. Like I think Microsoft's thinking, you know, the cadence and the update rate, they're getting some pushback and they're starting to respond to it.
Yeah, I mean, there are some breaking changes in .NET 7, and, you know, we're going to have to deal with that, but the performance is pretty freaking amazing.
Yeah, you can't argue with that. But the Blazor side in general, because it's all so much younger, is going to take more hits in their updates.
Actually, I don't think so. The Blazor component model is very, very stable.
You're happy with it now?
Yeah. I think it's been very stable, and even from 6 to 7, it's stable. But there are some new features that we're going to want to take advantage of. Yeah. But we'll talk all about that in a later show.
That'll come.
That'll come. Right now, let's roll the crazy music for Better Know Framework.
Awesome.
All
right, man. What do you got?
So you know that I've been doing this MSAL authorization stuff. On Blazor Train, and I did it in the .NET show with Maui XAML apps. Well, I also figured it out for Maui Blazor apps, which is a totally different animal. And there wasn't a whole lot of stuff out there to help. I sort of had to do some hacking and reverse engineering. But if you go to the .NETshow.com and look at episode 29, it's MSAL authorization in Maui Blazor apps, and that's going against an Azure AD B2C directory, and securing calls to an API with it. So it's the whole thing.
Cool.
Good stuff.
Nice one.
Yeah. Who's talking to us today, Richard Campbell?
Grabbed a comment off of show 1802, which is one of those shows we did on the road. I think it was NDC London with Victoria Almazova. When we were talking about measuring DevSecOps, you know, knowing we're doing a security-minded talk today, thought some of the stuff that Victoria was doing was obviously awesome. And unfortunately, this is one of those comments that did not migrate, but I was able to pull it from the old back end. It's from Rob Gardner, who says, great show as usual. It's interesting how the commercial world is struggling on how to get their heads around how to prioritize security. Yeah. Having been a nuclear code controller involved with securing ICBM launch codes, I think it would be useful to look at how we do this in the nuclear enterprise. The nuclear enterprise. Oh, Rob. We start with a broad statement describing what the overall goal is for our security effort and to what level, in probability terms, we are going to protect that.
The goal is 4 words. Don't blow shit up.
Easy with that button there, boy. Easy. We then identify what information we are protecting, what are the possible scenarios and outcomes that could result in losing control of that information, and identify the measures we need to put in place to protect against those scenarios to meet our desired level of protection. We then continuously test and reassess our assumptions. Now, he's talking about losing control of nuclear codes, so I think, there's some priorities there.
Yeah.
In the commercial world, I think a similar thing could be done. Start with a risk assessment. Break the results of the risk assessment out into scenarios. Figure out the cost of those scenarios and the probabilities. Now engineer your security solution. The probabilities and severities of the negative outcomes should inform your priorities. 100% protection is not possible, but you must have a way to prioritize.
Yeah.
Yeah. And the funny thing is, I know I've had this exact conversation with Dana over on Run As Radio.
Yeah.
Because this is what IT folks contend with, right? You're responsible for all kinds of things. And the boss just sort of says, hey, you got that security thing figured too, right? Then you've got to come at them with business language about return on investment and risk to spend time on security. Right. And it's a good conversation to have. And you do have to phrase it in the language that's going to make sense. Rob, thanks so much for your comments. And thanks for your service. Really glad you didn't have to launch any of those missiles. Yeah. And a copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and I read it on the show, we'll send you a copy of Music to Code By.
We'll also send you a free subscription to the Security This Week podcast, which is very expensive.
I don't know if that's true, but okay.
No, you definitely want to follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. I don't care what Elon Musk says.
The chief twit, and he's making it more true every day.
Oh my God. I don't know what you guys think about this, and I'll ask Dana about it when he comes on after I read this very short, concise bio. Dana Epp has been a builder and breaker for over 30 years now, and helps developers, testers, and hackers to find and fix flaws in apps and infrastructure. Outside of being an offensive security engineer, he's a Microsoft regional director and a Microsoft security MVP for over 17 years now, as of 2022. Welcome back to the show, Dana Epp.
Hey, guys. How's it going?
Good. Have you experienced any hiccups on Twitter since the Musk man took over?
You know what? This is going to sound silly, but one of the things I do with a lot of reverse engineering is we focus on things called sources and sinks, where data input comes in and where it gets consumed by potentially dangerous functions. On Twitter, we use the hashtag sink. And that got blown up when he bloody well walked into Twitter with a sink in hand and decided that. Wow. So all of a sudden, everyone was tweeting with the sink tag, and now we can't use it anymore.
You ruined your tag.
That's
hey, but
right.
The new Twitter is all about free speech, man.
There you go.
Except for that hashtag right there. We can't have that.
Can't have that anymore. You know, it's funny. You guys were just talking about the previous guy was talking about nuclear codes and protecting that. Mm-hmm. There's a wicked book that you need to read from Ross Anderson called Security Engineering, Building Dependable Systems. And I read that back in the 90s when the first edition was out, and it was hilarious because there's a whole section where they talk about how the default launch codes that were set at the actual silos were the same defaults everywhere.
Yeah. and they were like 1111111.
Yeah, exactly. So, you think about it, at the end of the day, like we've been having problems with security engineering for decades, and it doesn't get any better. It doesn't matter how good you try to build something if people use defaults for everything. Yeah. And so when you were talking about the nuclear, I was just remembering that book. It's a long time since I've read it. I think it's in its like third or fourth edition now, but
third edition. Yeah,
there's a whole section about nuclear codes will scare you when you think about just how bad it was back then. And not that it's any better now, just different now.
And how close we've come to nuclear war because of human error.
Yeah. Well,
several times.
It's the reality, right?
So. It is.
All right.
Well, Dana, you usually hang out with me on Run As. I think you're like at the you get a free sub level now for the number of times you've come to visit me. And you're one of the few folks that's got like a single digit show, a double digit show, and triple digit shows.
Yep.
But I mean, here we are on the dev side of the equation. What do devs need to think about in your world for security?
Well, I think it's interesting because a lot of things that are old is new again. And when we think about where developers are now responsible, in Run As, we always talk about, IT infrastructure and management and whatnot. But now as we start shifting more left, and developers are now becoming more important in the deployment side and in the configuration side, especially if you're talking about infrastructure as code or you're building out microservices and there's a lot of interdependent components and there's a lot of trust that we're now having developers to have to take on, when they're building systems. And so it's hard to build secure systems when you don't understand the threats that you're susceptible to and you don't always know what you're taking on as risk. So I think these days when I'm talking to developers, it's usually about what kind of trust are you having to bring in with the work you're doing? Just think about the resources and the loads that they bring on, right? These days you have VS Code and Visual Studio, and you might take a package from NuGet, or depending on what language they're writing in, they might be pulling it from some other package manager, where there's a level of trust that is immediately inherent that they take on without even thinking about who's responsible for that code. I know we talked about that a little bit in the last .NET Rocks we did, where we're talking about, this whole aspect of trust. But I think it goes further now because everything is API centric. Over 80% of the internet traffic that now flows is driven by APIs. And so everything that we do these days, like I know Carl was talking earlier about Blazor. Well, let's literally take a look. What does Blazor ultimately do behind the scenes? It's going to fire off to an API to consume some data, which is usually going to be almost in a raw format. As an offensive security engineer, I relish the idea of being able to see how a developer consumes an API, because these days they're leveraging frameworks to serialize and deserialize objects raw against the wire. So we have these APIs, especially in the microservices world, where you're consuming what's being sent across, and can you trust it? A lot of times you can't. And I don't think a lot of times developers are actually knowing or understanding that. They're trusting the frameworks to do all the heavy lifting. And that is an attack vector on top of the dependencies.
There's another part of this, which is developers taking the easy way out and using their entire data models, going across the wire and exposing the database structure, essentially.
Yep.
And then if you're doing that, somebody could just sniff all that stuff and see what it is, and then try to construct some API calls that insert or delete records or update records, that kind of stuff, and get the right cookies and the right keys, and go to town. I kind of learned that the hard way, but there's an art form to creating data transfer objects, and that it's not easy. You have to do a lot of work.
Yeah, and I think one of the things is if we look at there are governing bodies out there that are trying to help educate developers as going through. Like OWASP is a perfect example of that.
Sure.
There's the OWASP API Security Top 10, and what you're talking about, Carl, is actually something called mass assignment. That's actually one of the top 10 vulnerabilities, because a lot of times you have the capability when using these data models and serializing and deserializing them directly. From an attacker's perspective, that might be something we could take advantage of to get a privesk or to move off to a different way of getting it. So as an example, imagine you have a user object that's coming directly back from the database, and one of those fields is, a Boolean field that says, are you an administrator? Is admin?
Right.
By normal defaults, that's not something that you'll probably have in the front end and editable, except maybe when creating a new user, maybe there's a checkbox and you use that to say, are they an admin? So imagine this scenario if you're not paying attention and you think, hey, I'm filtering out stuff people can't see in the front end, but I can capture that and I can detect what that model looks like. I could modify that, and then I could give myself admin privileges. Now you're going to say, well, that never happens. Actually, it does. On one of the most popular SaaS apps out there, that was the exact way that someone was able to get not just admin privileges, but the actual cluster admin privileges.
Oh, man.
Simply because people were just serializing because they didn't know any better.
I also think that's going to be tough to detect that even happened, because it's still making a legit call.
Well, you can't, because they used the common thing. Exactly. And you pulled back that data. And sometimes it's not just that. It's when you start having embedded objects, more complex structures where it's not just their basic. Think of JSON, just how deep that can go. Yeah. When all of a sudden you start exposing, I look at things like complex objects where you might have the user object plus who created it. So now all of a sudden you have who is the creator of that? Not just by email address. It's usually an ID and possibly even like the email address or whatnot. So now all of a sudden you have this leakage of cross account scenarios, which is part of that whole aspect of mass assignment, and something called excessive data exposure. Because a lot of times the API should be filtering that out. You should have partial queries, right? You shouldn't be able to have the whole model extracted and delivered there. But the truth is, when we use some of the TAC tools we use, like Burp Suite, it has a capability of tracking all of those interactions and then overlaying it. So you'd be able to see the whole model anyway. So you'd look at the creates and you look at the puts and the posts, and you would be able to see what's the data there and almost reconstruct that model anyways. And I think .NET, that's especially when using things like Entity Framework, that makes it even easier because we see the whole structure of that, which can be to your benefit depending who you are. But it's always something to be looking for.
Oh, man, I'm just looking at Burp Suite thing, and this is a whole level of testing I just haven't done.
Yeah, and it's cool. Like I use it. It's probably one of my primary tools. So the two tools I use when I'm hacking APIs are, well, I have three really. The first one is Postman. And the reason I use that is that most developers, I'll be able to usually find the OpenAPI docs. So I'll be able to extract their Swagger and use that to construct the initial calls. But I'll proxy Postman through Burp Suite. So then Burp Suite's my middle proxy, and it allows me, that's where I actually will taint it. I'll never taint the actual Postman stuff. What I'll do is I'll taint it and change it into a malicious payload through Burp Suite and then fire that off to the API. So I still get all of the benefits of the session management and the cookies and the JOTs and access tokens, whatever's there, but I can actually decompile and break them down. It's actually kind of funny. Couple of weeks ago in one of my blog posts, I actually wrote how to use Azure's GPU enabled VMs to crack weak signatures of JOTs, because a lot of times you've got people that when they're deploying, they're not using really strong signing keys. And so you can use that if you can recover the signing key, which you can do by cracking it with Hashcat in Azure. You can recover the key, then use that to forge your own JOTs. So now if someone does something like has security principles in, let's say, scopes or roles inside of that access token, you could theoretically modify it, re-sign it, and now you're elevated into a new privilege. Now, this isn't normal. Like, good best practices for security coding is always telling you to use, much stronger keys and
sure.
But a lot of times, especially for developers and test environments, they don't always do that, or staging environments even.
What's the cost of using a longer, a tougher key? Like, this doesn't seem like that would cost anything. Why would you do anything other than that?
So here was the thing I did in my article, and I went through it. I decided I wanted to crack to see how far I could go, and I found that using a quad GPU Azure instance, it would cost me about $3 and about 15 minutes to crack a 16-character signing key.
Right.
And what's interesting about that scenario is, and that's checking the entire keyscape. So that's lowercase, uppercase, numeric, and all special characters. But as soon as you start going into higher, 7, 8, 9, it became infeasible. Like we're talking months to years. And I think at the end, when I think I got to 10 characters, calculating it out, it was going to be like hundreds of years. So it doesn't seem like it would be that hard to use a longer key. But
yeah.
A lot of times, especially when people are taking samples from like Stack Overflow, or they'll jam this stuff in here and they don't think about it. And so, it's funny though. So usually when I do an engagement, I'll always try to crack 6 characters, because for me, spending $3 to determine if they have a weak signing key is worth it. Because if they do have a weak signing key, I'm in. And so for me, when I do my recon, I usually don't try to attack the production instances. I'm actually looking for the staging, test, and dev instances, because as devs are doing this DevOps thing, they usually have multiple instances in their scenarios, and you can almost guarantee that the dev and test instances are not as hardened as the production instances are. And so you can typically get yourself into a privileged role in those APIs and see how they function. And then that might get you everything you need to be able to, figure out how to make it work in prod. So.
But I love that you just do a brute force demonstration using a cloud resource.
Yeah, right? Why not? It's funny. My Surface Book, it has no GPU on it. And so, right. When I tried to run it, it's like abysmal. It's like, you just don't do it, right?
Yeah, it's nothing.
But Azure has, and you don't have to use Azure. You can use, Amazon, or you could use
pick your
Google.
GPU.
pick your GPU in the cloud, right? And then you just pay for it. And so like, you don't want this thing running all the time, right? Cause it'll cost you like thousands of bucks a month. But, like I said, you can run this, when you spot instances in Azure, you run it at night when no one else is using it in the region you're in, you're talking, a couple bucks. It's nothing. And if you can find a weak signing key, it's worth it because that will find you some pretty crit issues to report because, hey, if you can forge a token to give you more privileges, the game's over.
Right.
Even if it's not vertical priv-esque, right, into a higher priv, even just horizontal, going in, being able to jump in as anyone else, simply because you can forge those tokens. Is a very interesting attack vector, which all comes because a developer didn't secure it properly, which gets us into one of the other like OWASP vulns, right? Which is security misconfiguration. It's really just because a lot of times, especially when building out microservices, you're using these default configs for infrastructure as code, deploying it out and not thinking about things like the signing keys for that service.
Mm-hmm. Just locking it down a bit, locking down a bit further. I mean, most of the time, the instinct is to turn all the security stuff off until you make it work.
Yep.
And then try and turn the security stuff on. But often we skip that part.
And when you have developers that are doing things like spinning up a test instance in Azure under their Visual Studio account to test to see how it's working, those are instances that we can leverage. And if you know how to scan and look for this type of behavior, which is just good recon, you can find them quite a bit. I've actually found staging instances where people had upgraded. So we actually found the CVE, detected that they fixed the problem. They deployed it into Azure, into an Azure Function app, but they didn't deprovision the staging instance. So what they did is they actually uploaded it using red-green. They flipped it. So they moved what was in staging into prod, but they never deleted the old staging instance. So
right.
Because we were able to detect that instance, we were able to go and attack that with the old code that was vulnerable, leveraged that, and was able to get into the production Cosmos database. So
you fixed the problem. You just didn't take away the weak one.
Well, a lot of times people, when they're looking at like an Azure DevOps or something, and you're doing a CI/CD pipeline that's deploying this stuff, it's easy to deploy and swap slots, but You're not always remembering to kill the old slot. And that should be part of the CI/CD pipeline, but sometimes it gets missed and you're assuming it'll age, because it'll age out over time, right? Like there are times, depending how it's configured, it'll kill itself out. But a lot of times if you forget or you have a longer period because you want to keep it there to fall back if something goes wrong in the deployment, if you forget, that might be an opportunity for an attacker. So.
Right.
Just leave it up and alive. So we talked about lots of authentication and authorization problems seem to be that when I look at this OWASP top 10 API security list, it's you haven't secured this properly.
Well, there's lots of different ways of looking at it, right? So like APIs these days, a lot of times are protected simply by an access token, right? Like that. Right. And there's nothing wrong with that. It can work and do its job. But a lot of times if you forget, especially if you're using something like if you're using decorators to apply the security that you want on a function or something, and that decorator is not properly applied, it's easy to miss it. And so if you're assuming the framework's going to take care of it and then you forget to set the decorator right, now all of a sudden, that attribute's not there, and now you're actually able to find a vulnerable endpoint that may not have the access control that you think it does. And in Burp Suite, there's an awesome tool called Authorize. It's like authorize, but without the H, called Authorize. And what it's designed to do is you log in with a low privilege user and a high privilege user, and you make sure that you take the low privilege token and you save it into Authorize, and then you browse the application as a high privilege user. And every time you go to an endpoint and it sees a new endpoint, it'll try accessing as the low privilege user to see if they can access it. So for the purpose of three things. One, looking for priv-esque to see if you have access to access resources you're not supposed to be able to. Also to test to see, can it work without any token? So like, did they forget to put in the access control on that endpoint? And you'd be surprised how many times, because in this agile world these days, it's easy to rapidly be rolling out new endpoints and missing something like that and catching it later. And so we love that, because when we're going and doing our app walkthrough to generate the traffic, we can automatically be testing all of those scenarios and immediately capturing it as we're going through that. And a lot of times what I do is I'll actually use a HAR capture, the HTTP archives that happen in your browser, and I will run that against the target in an automated fashion to replay. And so what happens is once I do that first run through, I can rerun that to retest all of those endpoints without having to do a lot of work, so that it's all automated. And then so every time we see a change that goes on in a target endpoint, we just run those all through and we're able to capture that. So when QA misses it by doing their manual testing, all that stuff, we can automate that flow because Burp has all that traffic and we know.
Yeah, that's what I was thinking. This seems like such a great candidate for automated testing. To just poke every single endpoint with every single token type, because they're all very repeatable and they don't have good UIs anyway. Like this is very difficult stuff to manually test unless you have your burps and your postmans. But if you put in automated tools for that, so that they simply poke every single endpoint and then kick back this didn't need a token, or this, this works with a low token versus a high token, like all of those kinds of things, you can, that's just a big matrix of test all the endpoints for all of these things.
Yeah. And when you think like in the old days, like the OWASP top 10 for like normal web apps, there was things like IDOR, right? Which is pretty simple. It's like, hey, if I can see a URL path in a GET and I can go and change that number, maybe I can access a different resource. Well, the same thing exists in APIs. We don't call it IDOR anymore. We call it BOLA, or broken object level authorization, but it's really the same thing, right? It's just that it may not always be through a direct GET. It might be through some structured query that might be in the body, or depending on how it's created and maintained. But it accomplishes the same goal. And so these tools can do all of that for you. Once you understand the pattern and what you're looking at, there are ways to be able to do that. And it's funny. There's an article, I have an article that's going out at the end of this week on, immutable GUIDs that aren't really immutable and talking about how it's actually possible if you're using like V1, GUIDs, those are actually predictable. And so if people are using, let's say it's a password reset that's using what they think is a unique GUID link, but it's time-based, you can predict those. And so you can actually generate, and I actually wrote a script that I'm giving away that you can actually run through and pre-detect and basically break the whole flow for even access control for like things like password reset, or the scenario that we had seen this in is a bank where they were using a unique link to accept the money that was being transferred for an e-transfer. And that GUID was actually predictable. So it was actually possible to forge a transfer, and accept it on the other end, all because of that.
Right. Yeah. Now I can absolutely see the password reset. It's like you take somebody else's email address, you fire it in for a password reset. Now you're not going to get the response back, but because you know what the likely GUID is, you just start responding with GUIDs until you get access. And now you could change. Now you do learn the password and you own the account.
Yep. Exactly.
I'm scared. Should we be scared? Seriously. I mean, it seems like there's so much we have to do constantly to be up on this stuff and to be aware of our vulnerabilities. If only there was a podcast or a resource that we could listen to,
He's scared, but not so scared not to upsell.
So, Dana, how about you? Like, you have your own media empire, blog, newsletter.
Well, yeah. So I've been trying over the years to help educate developers and testers and hackers on ultimately how to be able to learn how to do this in a positive way, right? So it's thinking of things offensively, but doing it in a way that when they're hacking APIs, they're getting access to this stuff. So I actually published something called The Ultimate Guide to API Hacking Resources, which is basically like this 18-page guide of all the online resources that can help you learn how to hack APIs, and that includes articles I've been writing over the years, and it also includes like some of the most popular testing resources for practicing, so that when people want to do this, they can. And so I actually created for you guys, there's actually a dedicated link. If you go to danaepp.com/.netrocks, that'll take you to that guide. And it's absolutely free, and it'll get you on my newsletter. So anyone who's interested in this kind of stuff that want to think about how to test their APIs as they're building them, it's a great resource. Okay. And every month I'm writing articles every week on different types of things, like, how to attack a jot with Azure, and how to break immutable goods, and these type of things. So if people are into that kind of stuff, hey, it's absolutely free. I'm not selling anything, so feel free to grab it and sign up, and give me feedback. So as people are wanting to understand what to do, especially as we're changing this world, right? I think we're moving more and more to microservices that are being built in things like .NET Core, and I think a lot of people are relying on the framework to do a lot of the heavy lifting without understanding the risks that they're exposing themselves to.
For sure.
And I think it's great just to always keep up on it and know what's going on.
And guys, hold that thought for just a minute while we take a moment for this very important message.
Hey, Richard.
Hi, buddy.
Raygun is our sponsor right now, and just so happens that we have JD Trask from Raygun right here with us for the next few seconds. Hey, JD.
Hey, guys. How you going?
We're great.
We're really good. But I have a question. It must be on everybody's mind. Why would I use Raygun over, say, App Insights, which is, built into Azure?
Yeah, well, firstly, I'd start by saying it's more important that you use something. As a consumer of software, I want everybody to use something.
For sure.
Yeah.
At the end of the day, App Insights, it's a good product. It's part of the Azure offering. Not everybody uses Azure. And also, a lot of those cloud tools, they're good. They're not necessarily great. And what we're trying to build, we are 100% focused on Raygun and what it is we're building here. And so you just naturally get a tendency towards a higher quality product. And so for customers where they need a little bit extra, maybe it's more detail, more insights, the ability to connect customers to the code issues, those sorts of things, they'll come to Raygun. But like I say, it's great just to start with something.
Yeah, what I like about Raygun is just what you said. If I want to find something quickly, I don't have to go through screens and filters and, is that what I'm looking for? Is that what I'm looking for? Yeah, so I appreciate it. And I hope you do too, listener. Go to raygun.com for more information.
Hey, this is Carl. And if you haven't heard my new podcast, Security This Week, you're missing out on an extremely serious look at the week's hacks and what they mean to you. Check out this little clip to get a hint of the searing insights you'll get by listening to Security This Week.
If 3 people have a secret and 2 are dead, you can keep the secret. Remember that.
More wisdom from Patrick Hines. Thank you very much.
I think that's a Russian proverb, actually.
Yeah, I know a lot of people who open a bazillion tabs and never actually reboot and just keep it all open.
Who would do that?
I could give names, but
I think I'm guilty of that. Yeah, we should be rebooting every day.
I reboot every day.
Yeah.
Honestly, add that and your cell phone once a week. Those are some strong recommendations.
You should reboot every day, and you should shower every day, whether you need it or not.
That's your STW homework, kids.
But if you get to pick one, reboot.
Reboot over shower. Ew. So I plugged in my webcam and it didn't work. So I unplugged it, plugged it in, couldn't get it to work. So I had this other webcam that I bought. It's kind of a no-name webcam, I think it was made in China.
Or Moscow.
And I got it because it was cheap. And I plugged it in, and all of a sudden, I looked like a colorized Ted Turner movie.
It works great.
It looks terrible.
What you'll find is a great feature of that camera is there's no turning it off. So
it's wonderful. It's actually 4K, so you get twice the size of crap.
Go to securitythisweek.com or listen however you get your podcasts. You'll thank me later.
All right, we're back. It's .NET Rocks. I'm Carl Franklin. That's Richard Campbell.
Hey.
And that's Dana Epp, and we're talking security, and hopefully you're sufficiently scared. Dana, what do you think of single sign-on, and the basic OAuth thing that everybody does now where, they put all their faith in their Google account or their Facebook account, and they use that to sign in everywhere? If your Google or Facebook account gets compromised, you've got a whole lot of scrambling to do, don't you?
Yeah, I think we have to understand that absolute security is a myth. With enough money and motive, anything can be breached. The question becomes, what's the motivation and what's its purpose? I don't think things like single sign-on are a bad thing, because I think the worst thing is that we have passwords everywhere and we end up using the same default password everywhere, and we end up on Troy Hunt's Have I Been Pwned, right?
Right. Well, there's another alternative, which is use password manager and have secure passwords.
Okay, sure. But then if I have the capability of breaching into the password manager, it's no different. I now have access everywhere, right? So like for me, I have a YubiKey. And so my YubiKey unlocks, it's my physical key that unlocks my password manager. It also unlocks my device. It also unlocks my access. So like I have my PGP on here, my keys. I have my SSH keys on here, and I use half keys. So they're EC
Right.
keys. So half is sitting on the machine, half is on my physical smart card.
Right.
And I use that to even when I digitally sign my commits in GitHub.
Does it work on a phone too, or do you have to plug it into?
Yeah,
this is
a YubiKey 5C, so it works on my phone through NFC.
Okay.
If I wish to enable it, I actually don't, simply because
Right.
I don't want the NFC to be the enabling part, because someone who's close by would be able to gain access. But that's fine by me. So, but what I do is I take advantage of things like the Azure AD backplane for identity, so that I have device trust. So the machines that I have a certain level of trust that's in there. And I use what I would consider adaptive multi-factor auth. So I have to prove my identity if I'm in an area that I've never been in before. I have to prove I am who I say I am, if it's on a reboot or on a new network. So that way I have some level of trust. But hey, someone with a monkey wrench going after my knees is still going to be able to take my YubiKey away. Like, we just have to be realistic about what are we trying to protect against. I don't think a single sign-on like using your Google account is enough if you're also not adding two-factor authentication on there.
Right.
And I think that 2FA should be with a hardware key. Like, so this is a UTF key. So it actually uses the universal second factor protocol. So when on my Google, I have to use this key. It physically has to be there to unlock that device, and then it trusts it for 7 days, right? And so it gives me a level of trust. I never sleep my devices. I always hibernate them. So they have to go into a security conclave to unlock.
Okay.
So like, those are all those benefits that are there. I do not allow GitHub commits without signing. So you cannot check in under my account, and you can't pull under my account on any of my private repos unless you have this key. And that's, or my other key. So I have a secondary.
And to be clear, you have a few keys, right?
Yes. So I have this.
I think I'm up to 5.
Yeah, so I have 3. I have one in my safety deposit box that's locked away. I have one in that I always have on my person, and I have one that I have at home. And
there are USB-A ones and USB-C ones. So, like, if you want to use the USB-C in the phone, that works just fine. I've done it.
Yeah, and I've got I have an adapter that goes from my YubiKey 5, which is A to C. So, and that works to like unlock my iPad and stuff. So,
right.
That gives you that.
I have given the advice for someone who is insisted on using single sign-on with Google. It's like, at least make the Google password unique. Yeah. Don't make it the shared password.
No.
And turn on 2FA, please, please, please. Preferably not 2FA with text messages, because it's the lousiest 2FA.
Okay.
Right. And these days now, with the people hijacking phones and like, the local mobile carriers are not a strong point. So It becomes easy for people to dial in, social engineer. That's how a lot of the Google accounts are getting broken that have 2FA. It's simply that they're using SMS. And so they're just dialing in, tricking the mobile to reroute. And then the next thing you know, it's going to someone else's phone or email. Yeah. And that's enough for recovery. So use a physical device. And these YubiKeys aren't expensive. I think these ones are like on sale. Like Black Friday's coming up this month. I'll bet you can pick them up for like $30, $40.
It seems
I think it got down as low as $20. Like, they get cheap on Black Friday.
I use LastPass, and they have an authenticator app, and so that's a really great way to use 2FA. So so once you get through with the password, which you should be, changing, or maybe you have a YubiKey, then you still have to go open your phone and say, yeah, that's me.
Yeah. And you can use things like, if you use so I have the Microsoft Authenticators as a fallback. So like devices where I have to do digitally signing anything, I use my YubiKey because that's where I have my signing certs and stuff. But I have for my Microsoft account, I do have the authenticator that I can use the passwordless auth, where it basically fires it by an app message. And then you have to select the number, which number is the one that was sent to the app. And that's another form of multi-factor auth, but it's not SMS, right? That is a secured end-to-end between Azure AD and the Microsoft Authenticator. And that works. Then there's TOTP for those services that don't have it. So for Google, that is one of my fallbacks, is I do have the ability to use the TOTP, but only in Western Canada. So that, if I'm really bad, but I'm overseas, I can't. It's not an ability for me.
So when you set up the TOTP authenticator for Google, you said only allow this if I'm in locale.
Yeah. And I can only do that because I actually have access to Google for Business, the enterprise stuff. So the free stuff doesn't have that. But that gives me my ability, because I do have a Google account that has access to sensitive resources with Google. So it's just important. So.
Can we swing back to the top 10 list? Because I think we've certainly talked about all of the authorization and authentication problems, but there's also the rate limiting stuff. And we did a show years ago on the Azure API management. I mean, do you recommend tools like that? What's the right way to deal? I think that's primarily for rate limiting, but it also helps with auth, doesn't it?
Well, it does, because you can offload a lot of the intelligence to the API management gateway. The trick with that is understanding how it functions and works, because if you rely on everything at the gateway, once you're past the gateway, then what? And I find that there's the entire sites dedicated to WAF bypass and mechanisms for figuring out how to get around the gateways. And if you look at things like function apps that are mapped to the API gateway, and then you still can access the function app directly if you know the URL, that's a problem. You're bypassing their. Now, you should be able to turn that off, but most people don't know how to configure that. And so relying on something like that only works if you understand how to harden the back-end services it's going to call and how you're going to use it and where you're going to trust it. But it does give you the ability to do things like creative transforms for things like claims. So like now all of a sudden, internally microservices can only talk to each other, but when coming through the gateway, we can transform this scope or role into a different claim that may be allowing it to reach out. So there is some benefits to do that, but that also adds more complexity. And sometimes
you do have to learn the tool. But
that's right.
I'd rather not roll this stuff myself. Like if there's a set of tools already in place, I'd rather do that class and learn that tool and know they're maintaining that code.
Well, the Azure API Management Gateway is actually pretty good because it actually does a lot of the heavy lifting for you, so you can get educated on that. But I think they do a terrible job of helping you understand how to harden the backend services when you do that.
Yeah, I almost I want a template in Postman where I say, hey, all my endpoints are supposed to go through Azure API. Tell me where I've screwed this up.
Yeah, exactly. Yeah. The other side of it too, though, is things like rate limiting is a perfect example about understanding not just the limiting, but how to do retry logic reasonably. Because there are going to be times where people are going to make mistakes, and the last thing you want to do is lock someone out or get overly inherently aggressive so that people trying to do their job, but something goes wrong, they're getting locked down or blocked or prevented.
Well, especially, you're describing a developer learning a new API.
Yeah.
And they get rate limited out while they're doing development. That's a good way to make someone angry in a big old hurry.
And then what's the next thing they do? They remove the code that provides the limiting. And now all of a sudden, then that doesn't get added back in. And then this becomes a problem. The other side too is not a lot of developers don't understand things like incremental back off retry logic. Right. And so what ends up happening is they just hammer on the thing. Oh, it's not working. It's not a 200. I'll just keep sending it. And they're not realizing the 429. Like they got to honor that stuff. And sometimes they expect the framework to do the work for them, and they don't always. And so,
gee, if only there was a framework for that.
I think the other side of it too, though, is that they don't understand the business logic behind the scenes that could affect rate limiting in a way that's not expected. I.e., trying to rate limit the reset password functionality, very important. right? You don't want people to be purposely
be able to hammer it. Yeah.
Hammer it. But there are times where you can't rate limit certain things, right? So it's like, imagine a login endpoint that is exposed to someone behind a NATed gateway. There has to be some logic that has to be done, and it's a lot harder to rate limit that because you might have thousands of people coming through from a private network that it needs to access that service. And so until you validated them, you don't know who's who in the zoo. So there's this balance, and you really got to look at it from a risk perspective. What are we trying to defend against? But I think rate limiting, the other side of rate limiting too is people just not understanding. So let me give you an example. Imagine you have a filtering logic for pages. And so you're going to have an API endpoint that says, I'm going to bring back 20 objects at a time. But it becomes possible that you can remove that and increase that to 2,000. Well, now all of a sudden you're going to put so much load on the database to pull back the resources.
The number of calls isn't the problem. The size of the calls is the problem.
Right. And and from my perspective as an attacker, I like to see that because then I can extract more information quickly. And that's a bad thing, right? And especially if I have the ability to skip and move and play with it in different ways. But it's also the way in going back when I want to do things like fingerprinting the APIs to understand maybe what's the operating system and the programming language used on the API, which is important when I'm looking at it from attacking it from like understanding the language behind the scenes. If I want to do something like an injection attack, a template injection attack as an example,
right.
I want to understand what the language is and I want to understand what templates might be there that I could abuse. And if I have the ability to fire off multi-megabytes of data that will bypass. Because here's a funny thing, like even the Amazon WAF as an example only looks a certain amount of bytes into the payload. So it's actually possible for a lot of these WAFs to bypass them by simply sending so much data that they're just going to ignore through the WAF side, but then bleed over the extra. And then that doesn't get filtered. So you can have all clean data for 2K or 3K or whatever it may be. But right at the edge at 4096, you can actually have your payload. And these type of things have been how hackers have been getting around a lot of this stuff simply because people aren't accounting for size of payloads.
Right.
Like if you know that your object can never be more than X, why do you allow anything larger, right? Because it's extra work to have to validate that stuff. And when you're serializing and deserializing, not just for denial of service type attacks, but abuse, being able to modify or manipulate, there's things like whysoserial.net, which is a .NET payload generator for deserialization attacks. So if you know how it works, you can actually generate payloads that can give you reverse shells from your API, just simply by knowing how to cause a deserialization attack that will basically have the deserializer be manipulated and run code in a different way than you expect it to.
Wasn't there a 0-day about the shell, proxy not shell, or something to do with Microsoft Exchange recently? And that begs the question, Richard, are you still running an Exchange server in your closet, sir?
Yes. Is it basically down to its last account? Yes. It's pretty locked down. Do I want it turned off? Oh yes.
So what happened with the Exchange stuff?
Oh, dude. I mean, it's just after the success of Hafnium, which was last year, I think it just turned a bunch of black hats towards the vulnerability of old Exchange servers.
Right.
And they've just been going at it ever since. But I put out a bunch of joke tweets on the run-as side about how bad that last wave of of Exchange patches were, because it literally was, here's your patch to fix this. Oh, it didn't actually fix it. Okay, here's the fix for the patch to fix it. Oh no, that created a new vulnerability. Like it was just this chain of
that was the intern project of the week, maybe.
Yeah, I don't know.
Well, you got to think though. A lot of Microsoft moves so fast, and so the people that were responsible for building that code eons ago are no longer even.
They're not
there.
around. Yeah,
and so
the focus of the best guns in Exchange are on the online product, not on the on-prem product. So you kind of get this B team effect, right?
Yep.
Yeah.
Anyway, yes, no, that thing really does need to be turned off, and it's interesting how hard. I mean, I got all the most important payloads off of it years ago, more than a year ago now. And those last little bits, they're a pain in the ass.
So is it like a customer that's still paying for it?
No, it's old accounts that can't be moved easily. I got to take that thing apart. It's that kind of stuff.
You can't just turn it off.
It's just not that. If I turn it off, other things break. So you just got to clean the last ones up. Yeah. You got to put the hours in.
Yep.
It's a winter project, right? When things get quiet in December.
Wait a minute, is that after or before the book is finished?
The book is God save me. But also like that hardware in my rack, that stuff's aging out. Like they're all ticking time bombs now. Right. So I really need that stuff turned off. And again, I moved over. It's easy to transfer the coherent payloads onto new hardware, right? There's a bunch of stuff running in Synology, a bunch of stuff running in the cloud, all is well. But getting the last of it done.
Well, you know what? Maybe this winter sometime I'll take a trip over there, and it might be a little easier with a buddy with a bottle of scotch standing behind you. What do you think?
I don't know. We'll figure it out. It's all possible. It's just taking the time to sit and plow it through.
Sure.
Anyway.
It's funny when you think about how much we rely on old things, right?
Yep.
A lot of times. How much do you think, when you're thinking of some of the code that's out there, have people taken dependencies on libraries that haven't been updated? Mm-hmm. Like, I can't remember the report, but there was a report that came out this year, by a vendor where they were showing that on average, and I'll get you the link to that report so you can add it in your show notes. But they were showing that, companies take dependencies that sometimes last 4 years past when there's been updates. So in other words, they have 4 years of potential vulnerabilities that are in these open source components. And that more than, I think it was 80% had projects that haven't been maintained for 2 years. So when you think about how quickly the internet moves and how we take these dependencies so easily as developers, because they made it so easy in our IDEs. Like, you just think of VS Code or Visual Studio and just how easy just to consume something in NuGet is. And we put this inherent trust. And sure, like, popular packages might possibly be utilized, but we've seen things like, the event stream package that, someone had actually put in, they've actually worked and put useful code and got themselves into the repo, eventually got themselves into a maintainer, had added a dependency of their own that they then turned into malicious, and it went on. No one noticed for years. And it's like those type of scenarios are becoming so realistic. There's actually this really cool, comic I have on it where that I saw on Twitter where they were showing this huge monolithic app, and there's this little tiny block at the bottom that's holding it all up.
It's another great XKCD.
It's exactly what it is, and it's called dependency, and it's like managed by a 30-year-old in Kansas.
Some poor random guy that's been maintaining it without any help. And it's we've got these shows out now talking about the problem in open source, and we didn't even address this with David Whitney, but it's like, hey, that maintainer that nobody seems to get around paying? What happens when a state actor shows up with a briefcase full of money and says, "We just want to put a little code into your project,"
Yeah,
and you get to pay off your mortgage.
Well, think about when Heartbleed came out. They went and did the research and found that the OpenSSL that was the cause of that only had 4 maintainers. Only one of them was actually doing it for a living. The other 3, it was all part-time. And the amount that they had spent was it was nickels. And every device was relying on that at the time. Yeah. And we do that all over the place. And it's actually what scares me now is not just the code that gets deployed to prod, but it's the extensions that are in things like VS Code. I start thinking as an attacker, how interesting would it be to be able to take an extension that gets injected to a developer's machine, which then could give me a foothold on their machine, which then would allow me to get access to their source code. So all of a sudden, and so people are going to say, oh, well, we always check our dependencies and we verify. Oh, great. But did you check the extension that you trusted? Like, there are typo squatting extensions. Just go search Python in VS Code and see all the different packages, which ones are from Microsoft, which ones are not, which is from people that are more popular. And all of a sudden we have this inherent trust in the ecosystem. And that is exactly how a state actor would want to leverage that. If I want to get into, let's say, I don't know, into a large corporation, I'm just going to find out what their tooling is. I'm going to put a extension that looks right, and someone will pick it up. Or dependency confusion. That was an issue that happened in 2021, was huge, where people were able to say, hey, if I can detect what a private package name is, and I can put it in a package manager repo as public, you'll download that first, because you always will look for that kind of resource. And people go and say, well, people don't know the private names. Well, this year, there was in NPM alone, there was a timing synchronization attack on their API. So it was actually possible to guess the names of private packages belonging to major corporations, leverage that with this other attack with dependency confusion. Now you've got this ability to
guessing passwords. I mean,
yeah,
you're
exactly.
actually using...
And now you're on the developer system. And once you're on that system, now you're able to get access, and you can inject code into their, in there without them knowing it, possibly. Hopefully human peer review will catch that. But then there's other things like adding a dependency that you're not counting on, which could be sit dormant and then leverage later. And crypto miners are loving that. Yeah. Cyber criminals are loving that kind of stuff, because people take a dependency without even thinking about it, because, hey, it's popular. And if it's popular, that's there. And most of these popular packages, especially things like NPM, those packages there's people with 400, 500 packages. They're not maintaining them. People will fork them, rename them something similar, and people will draw them down. And that's a risk. And I don't think people think about that.
Dana, what's next for you? What's in your inbox?
I can't talk about it. There's things I'm working on that are
to kill you.
Security guys.
It's around. There is an article that's coming out. So some of the stuff we're talking about, actually, interesting enough, there's an article coming out in the Journal of Defensive Software Engineering in January that covers a lot of, from an attacker's perspective, how would we pollute developers to gain access to systems? So I'll send you guys a link to that when that gets published. So
all right, and send me some anti-pollution spray, will you? Because
well, yeah, you know, my goal is just to keep doing this. I love being in the place where I am in my life, because I have the opportunity to be able to help educate the next generation of developers and hackers on how to make more defensible code and what to look for. And I think the best way to do that is to think about how would adversaries want to, or how would they get into our code bases. And when we hear now, like 80% of all traffic is driven by APIs are the place this is going to happen.
This is where we're going to get hit.
And you got to
where we're going to get hit.
You got to think evil a little bit.
You got to, but it's hard because not everyone can think like an attacker, and that's okay. But I think from a developer's point of view, and very rarely do we ever see developers who don't care about the security of their code. They just don't understand it. Yeah. And so if we can find ways to showcase that to them, in a way that makes sense, then that also opens their eyes. So, a best way, if you want to follow what I'm doing, just go to danaepp.com. And just check out the articles as those get released, and join, grab the ultimate hacking guide, and you'll get on the newsletter, and I'll keep you up to date on what's going on there.
That's great, Dana.
Awesome.
Thanks very much. It's been a pleasure talking to you.
Always a pleasure, guys.
All right. We'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and, of course, in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time. Got a transmitter band by the FCC. Yes, I'm a toy boy. Life is hard.